Right, inequality proofs. So just a couple of points before we start. Right, if A is greater than B, right, then you can bring over the B. That means A take away B is greater than naught. For inequalities, it's always easier to prove the inequality is greater than naught than it is that it's greater than 4 or greater than 10 or something. So always bring everything to the left and make it greater than naught before you try and prove it. Right, remember any number squared is greater than naught. Okay, so if you turn everything on the left into a square, right, you've proved. Right, and the third point I need to make is if A is greater than B, right, so if one thing is greater than the other and B is greater than C, then obviously A is greater than C. We'll be using that a lot, okay, that if we're trying to prove one thing is greater than the other, but we take this and we prove it's greater than that, then the first is greater than the end, okay. So prove by induction, example 1, prove by induction that 2 to the power of n is greater than n squared for n is greater than or equal to 5. Right, that's important, girls, because this one doesn't start at n equals 1. So our first step was prove it's true for n equals 1, but it's obviously not true for n equals 1 in this case. So here we prove it's true for n equals 5, which is the first time it's true. Okay, so that means 2 to the power of 5 is greater than 5 squared. So 2 to the power of 5 is 2, by 2 is 4, by 2 is 8, by 2 is 16, by 2 is 32. So 32 is greater than 25, and that's a true statement. So part 1 is done. Okay, so now we assume it's true for n equals k. Assume it's true for n equals k. Right, so that means 2 to the power of k is greater than k to be squared. Okay, that's your true statement. Right, then we have to prove it's true for n equals k plus 1. So it's prove it's true for n equals k plus 1. So we're trying to say is 2 to the power of k plus 1 greater than k plus 1 to be squared. Right? Is that true? Okay? So, right, okay. So, we start with our true statement. So for our proof, we start with our true statement again. 2 to the power of k is greater than k squared. Fact. Right? We want to investigate this. Okay? So how about I multiply each side by 2? If I multiply each side by 2, right, is greater than 2k squared. So I've multiplied each side by 2. Right? I've multiplied each side by 2. I've multiplied each side by 2. Right, okay, so at this side that's 2 to the power of k plus 1. So I know 2 to the power of k plus 1 is greater than that. That's a true fact. Okay, because that was true, I multiplied each side by 2, so it's still true. Okay, so this is a true fact. Okay, so this is what I'm trying to prove. Right, okay. Is 2 to the power of k plus 1 greater than k plus 1 to be squared? But I know that 2 to the power of k plus 1 is greater than 2k squared. So my question is 2k to be squared, is that greater than k plus 1 to be squared? Right? Is that true? Because if that's true, so if that's greater than that, I know this is greater than this, so this is greater than this. That's the third point we wrote down. Right? If this is true, then this is true. Okay? So off I go and try and prove this. Now this is the point, girls, where it's really hard to prove if that's not naught. Right? Okay? So what I'm going to do is I'm going to square it out. Right? K squared plus 2k plus 1. Right, this this is what I'm trying to prove, okay, but that's really hard to do, so I'm going to bring everything over to the left. So if that, okay, 2k squared minus k squared minus 2k minus 1, is that greater than 0? Okay, right, so is k squared minus 2k minus 1 greater than 0? 2k squared minus k squared is k squared. Right, now, this is no factors for this, okay? But remember, I'm all about squares, right? Okay, so what I'm going to do is I'm going to complete the square for the first two. So k squared minus 2k, remember to complete the square, you have the coefficient of k and you square it. So have it as 1 squared and 1. So if I put in a plus 1, I must take out a minus 1, and I had the minus 1 there again also. Right? Okay? So that would be the first three there. I can factorize that, and that's k plus 1 to be squared, right, minus 2. Is that greater than 0? Right? Okay, but I know k has to be greater than 5. K has to be greater than or equal to 5. That was one of the conditions, right? So that means k plus 1 to be squared, take away 2, has to be greater than 0, doesn't it? Because if you put in a 5 there, take away the 2, like the smallest that's going to be is 6 squared, is 36, right? Or so, yeah, the smallest that's going to be is 36, so it's definitely equal to 0 or greater than 0. So now we've approved. So this means, right, so if this is greater than this, that means this, which is 2 to the power of k plus 1, must be greater than that. Okay, so that implies, two lines and an arrow, right, that implies that 2 to the power of k plus 1 is greater than 2 to the power of k plus 1 to be squared. So then you write your 4 lines. True for n equals 1. Sorry, it's not true for n equals 1. It is true for n equals 5. It's true for n equals k. And then it's true for n equals k plus 1. And then your last line, therefore it must be, therefore it's true for all n, element of n, but there was a condition, right, and n is greater than or equal to 5. Remember, that was a condition. Why did I write true twice? Right? Okay, so that's example 1. Okay, example 2. Prove by induction that n factorial is greater than 2 to the power of n. Again, watch it, right? It's n is greater than or equal to 4. So step 1, prove it's true for n equals 4. Okay, so is 4 factorial greater than 2 to the power of 4? 4 factorial, remember, 4 by 3 by 2 by 1, which is 24. And 2 to the power of 4 is 2 by 2 by 2 by 2, which is 16. So yes, it is. So it's true. That's the first step done. Right? Assume it's true for n equals k. So that means k factorial is greater than 2 to the power of k. Fact. Right? Okay, that's my true statement. I know this now. Right? Prove it's true. For n equals k plus 1. So you're trying to prove, right, is k plus 1 factorial greater than 2 to the power of k plus 1. Okay? So your proof. Again, I'm starting with my true statement. So, my true statement is k factorial is greater than 2 to the power of k. Remember, k factorial is k multiplied by k minus 1 multiplied by k minus 2 all the way down to 1. Okay, is that alright? Okay, so k plus 1 factorial is k plus 1 multiplied by k minus 1 multiplied by all the way down to 1. From here back is k factorial. Okay, so k plus 1 factorial is actually k plus 1 multiplied by k factorial. So what I'm going to do is I'm going to multiply each side here by k plus 1. So it's k plus 1 multiplied by k factorial. Is that greater than k plus 1 multiplied by 2 to the power of k? Sorry, this is a fact. Because this is true, so if I multiply each side by the same thing, it's still true. Okay, so remember this is k plus 1 factorial is greater than k plus 1 multiplied by 2 to the power of k. Okay, so then I'm trying to prove that is that greater than that, right? But I know it's greater than that. So if I prove that, sorry, I know this. So if I prove k plus 1 multiplied by 2 to the power of k, if I prove that's greater than 2 to the power of k plus 1, I have my proof done. Okay, so what I can do is, right, okay, I'm going to break this up. I'm going to leave this for the moment. Okay, 2 to the power of k. I'm going to break that up into 2 multiplied by 2 to the power of k. Okay, so then I can divide each side by 2 to the power of k. So is k plus 1 greater than 2? But because k is greater than 4, was it? K was greater than or equal to 4. The lowest that can be there is 5. So that's clearly, this is true. So if that's true, then your original statement was true, which is, that implies that k plus 1 factorial is greater than n to the power of k plus 1. So then you write your 4 lines. So you say it's true for n equals 1. Sorry, it's true for n equals 4. True for n equals k. Then it's true for n equals k plus 1. And then that means it's true for all n, element of n. Don't forget to put in the condition though, where n is greater than or equal to 4. Okay? That was example 2. Right, example 3. Right, okay, prove that 1 plus x to the power of n, right, is greater than 1 plus nx, right? So for n is greater than or equal to 1. Okay, we're good here. Right, okay, so prove it's true for n equals 1. So that means everywhere I see an n, I'm going to put in a 1. So 1 plus x to the power of 1 is that greater than or equal to 1 plus 1 times x. And over here you get 1 plus x. And over here you get 1 plus x. So it's greater than or equal to, so that's clearly true. So that's that bit done. Okay, so then you're going to assume it's true for n equals k. Assume it's true for n equals k, so that means 1 plus x to the power of k is greater than or equal to 1 plus kx. This is a fact that we're going to use, right? Okay, then we're going to prove it's true for n equals k plus 1. So we're trying to prove is 1 plus x to the power of k plus 1, is that greater than or equal to 1 plus k plus 1 times x? That's the question. Okay, so with your proof, you start with your fact. So my fact is that 1 plus x to the power of k is greater than or equal to 1 plus kx. Okay, that's my fact. Now, looking here, right, this is what I'm trying to prove. So if I multiply each side by 1 plus x, so if I multiply this side, multiply by 1 plus x to the power of k, and I'm going to multiply 1 plus kx, and I'm going to multiply that by 1 plus x. That is also true, isn't it? Right, okay, because I've just multiplied the side by the same thing. Okay, I'm moving this up. Right, okay, so that means at this side I get 1 plus x to the power of k plus 1, and I know that's greater than or equal to 1 plus kx multiplied by 1 plus x. So that's also a fact, right? Fact. Okay, so what am I trying to prove? I'm trying to prove I'm asking myself, is 1 plus x greater than this number? Or sorry, greater than this. So I know it's greater than this. So if this is greater than that, right, the whole lot holds true. So if, right, sorry, is 1 plus kx times 1 plus x, is that greater than what I'm trying to prove, 1 plus k plus 1 times x? Now, it's really hard when there's stuff on both sides. So what you want to do is multiply out both sides, bring everything to the left, and try and prove is it greater than naught. Okay, so multiplying out here, I get 1 plus kx plus x plus kx squared. Multiplying out at that side. Greater than. Multiplying out this side, 1 plus kx plus x. Okay, as I say, you can't do this, it has to be greater than 0 in order to prove it. So let's bring everything to the left, right? Plus kx squared minus 1 minus kx minus x. So you're trying to prove is that greater than 0, right? Okay, so lots of stuff cancels out, and the x and the minus x. So we're left with kx squared. So is kx squared greater than 0? Well, x squared is definitely greater than 0, isn't it? And k is greater than or equal to 1. So yes, this is true. So if this is true, then what I'm trying to prove is true. So what I'm trying to prove is 1 plus x to the power of k plus 1 must be greater than or equal to 1 plus k plus 1 times x. So that means, therefore, or implies that that is greater than that. Okay? So then we write the 4 sentences. True for n equals 1, and it was in this case, n equals 1. Sorry, true for n equals 1. You write true for n equals k, then it was true for n equals k plus 1, and therefore it is true for all n. Okay, right, you're going to try a few of those for me. Right, okay, so those are on page 506. Have a go at 1 to 4, and I'll post the solutions to those later, okay?